Let's move into 8.2, and we're going to start looking at division properties of exponents, which is very similar to the multiplication part. So just as a quick review, if I do 2 to the third times 2 to the fourth, when we're multiplying and we have the same base, remember these are the bases, these are the powers, that we have 2 to the 3 plus 4. We add those together, which is 2 to the 7th. So that's what we have when we do the addition or the multiplication of this stuff with the same bases as we do the addition. So when we're doing division, we do subtraction. So in this particular case, we would subtract them, but we'll go ahead and show you why we do that. But let's say, of course, we have 2 to the 6th. Remember, that's 2 times 2 times 2 times 2 times 2 times 2. And then divided by 2 times 2 times 2. You'll notice that these 2's cancel. How many do we have left? We have 2 to the third, which happens to be 8. But notice, if I subtract those two numbers, that's where I get the 3 from. So I could just do a subtraction and I get the same answer. So applying that rule, x to the 10th divided by x to the third is x to the 7th. So we can see that in this particular case. There is another piece that I want to make sure that you understand, though, is that notice that in this case, the numerator power is greater than the denominator power. So we subtract them and keep the number in the numerator. So in a sense, we really have x over 1, 2/3 over 1, or 8 over 1, right? We have 1 down here because all those things canceled. They didn't become 0, they became 1. So what does that mean? So if I have x to the 4th over x to the 15th, oops, I don't know why I put that down there. Anyway, so if I have x to the 4th divided by x to the 15th in this particular case, of course, notice that this power is higher. So that's supposed to be 15. So this power is higher down in the denominator. I still subtract those numbers. However, I keep my x value in the denominator. So this would just be 1 over x to the 11th. So notice how I have it written that way. Because we do subtract these two, but because the higher power is in the denominator, we keep our answer in the denominator. So it will work out that way. This is kind of your intro to the next section, which is 8.3, when we start looking at negative exponents. But right now, we're not going to worry about that. Just keep in mind this particular rule. Okay, jumping into some problems. First one, notice we have p to the 12th, t to the third times r divided by p squared, t r. So what we're going to do is we're going to combine terms together in the division part. Remember, everything is multiplying or dividing, so we can do this property. If we had addition or subtraction in there, we could not do this. So p to the 12th divided by p squared is p to the 10th. T to the third divided by t, remember there's a 1 there, so it's t to the second power because we subtract those, and then the r's cancel, so those just go to 1. So therefore, my answer would be p to the 10th t squared. Okay, in this particular case, we have some numbers and we have some variables. So we just do our regular division. Of course, 9 is in the numerator, so we do 9 divided by 3. 9 divided by 3 is 3. D to the 7th divided by d to the 6th, we subtract the powers. D to the first, so just d. So our answer would just be 3d. Okay, and this one's going to be reversed. I'm going to go over this one, which is that new property, in the next video.